Alright, welcome back. My name is Piyush and this video will be implementing this wonderful project. This might look complicated or overwhelming at the beginning, and this is not just it, and I will have one more architectural diagram after this. But just to give you a gist of it, what it is, it's an end-to-end implementation of an Azure project in which we'll be implementing everything from scratch using Terraform, as you can see. And it does not just include the AKS cluster, it also includes Argo CD flow. So we'll be implementing GitOps using Argo CD for end-to-end CI/CD drift detection, and so that it acts as a single source of truth. So this is what we'll be discussing at the first. It's the infrastructure provisioning part. Then this is the application that we'll be deploying. This is the overall flow of the application that we'll be deploying using Terraform. So we'll go through all of these, and then I will walk you through the code repository, all the like important files, what we are doing, why we are doing, and all the nitty gritty of it. And then finally, I will show you the demo of how to provision everything and how to test it end to end. Now, this is just the architectural diagram and this is the implementation of it, but what I want from you is to implement everything by yourself. Yes, you can take the help from the video, you can take the help from the GitHub repository that I will be sharing. It will have all the snippets, everything will be there. Still, if you practice it by yourself, if you try it out yourself, and when you face the issue and when you actually fix the issue by yourself, then only you should be able to get the concept in depth. Then only you will be able to explain in the interview that yes, while implementing this project, what challenges have you faced and how have you fixed it. So make sure you do that by yourself. And yes, while implementing this project, you might face many issues. Some issues you won't be able to solve, let's say. So for that, feel free to ask help. So you can comment over here or you can reach out to our CloudOps community. We have a wonderful Discord server with 5,000 plus members as of today. So reach out to the Discord server and ask for help. Provide all the details that you can. Like, these are all the steps that I have performed. This is the issue I'm getting. This is my code repository and everything. If anyone can help me. So we have many wonderful people over there who are always ready to help you. So make use of it. Feel free to ask for help. The link will be there in the description section itself. Okay. So let's start with the introduction. I'm just having a little cold, so ignore my voice. Let's start with the first one. Okay. So what are we doing over here? We have a Terraform. So we have a DevOps team, right? DevOps team, what they will do, they will apply the Terraform files to provision multiple environments. Okay. So we have created the Terraform in such a way. I will walk you through that. Don't worry. So we have created it such a way that the same code repository can be used to deploy files across multiple environments. We can provision multiple infrastructure using the same code repository, and we have segregated with separate backend files, separate Terraform var files, etc. Right? So once you apply the changes, then a resource group will be provisioned which will have all the required infrastructure component. What are these components? So it will provision a resource group, then it will have a virtual network, and a virtual network will have a virtual machine scale set. Virtual machine scale sets is needed to provision the nodes of an AKS cluster. Okay. Now we'll also be installing Argo CD using Helm inside this repo, and it will make sure that all the changes that you do in the GitHub repository for your deployment manifests and everything, it will be automatically tracked by Argo CD and synced to the AKS cluster. Okay, so this Argo CD, if you are new to the concept of GitOps, what it does, it acts as a single source of truth. Okay, so let me just write it down over here in case I forget. Single source of truth. I'm not sure if the text is visible enough, but let me increase this more to 60 pixel. Okay. Just remember this concept, single source of truth. What do we mean by that is whatever is there in your GitHub repository over here, right? So that will be a single source of truth. You have provisioned the AKS cluster with some application deployed on it, right? Now, if someone try to make changes to the application over here directly on the environment, it won't let you happen. Or even if it let it happen, there is a reconciler running which will make sure that your GitHub repository will always act as a single source of truth. Meaning, whatever is there in GitHub repository, only that will be your application's configuration. If you make changes over here, it will be overwritten again with this GitHub repository manifest. Okay, so that do we mean by single source of truth, and this is also called drift detection. Okay, drift detection meaning if there is any drift in the configuration, so we actually lay down all the desired state of infrastructure over here in the Git repository. Okay, so this is like our application should be. So it will have, let's say, 2 replicas, it will have a front end, back end, it will have a service, it will use this particular container image and so on. So this is the desired state of the application. Okay, so that desired state of the application is there in the GitHub repository, which will act as a single source of truth. Now, if there is any discrepancies between desired state and the actual state, so here is the actual state. If there is any discrepancy between the single source of truth and the actual state of the infrastructure or the application, then it will reconcile the changes. It will detect that there is a drift. Okay, so that's what we mean by drift detection. So when it comes to GitOps, you just need to remember these two concepts: single source of truth, drift detection, and it helps you with the CI/CD of the application. Okay, so let me just walk you through this code, this diagram one more time. So we have a DevOps team that apply the changes, Terraform files, everything will be there in the GitHub repository. We clone it and then we apply the changes. It will provision this infrastructure. This infrastructure will have an AKS cluster. AKS cluster needs some secrets, some confidential data that will be accessed from the key vault using a managed identity. Okay, then Argo CD application will be deployed, which will take care of your drift detection and your GitOps. Okay, and it will be installed and managed by Helm. Then it also create an external load balancer on which your application will be accessible, as well as your Argo CD server will be accessible, because your Argo CD server also will be a public facing application. Or if you want to keep it internal to your organization, yes, that's another possible solution that you can apply. But in this project, I have exposed the Argo CD server and the application on the as external via ingress. Okay, so your DevOps team can access your Argo CD application, and all your application users can access the application on an external port and external DNS. Okay, so this is from the infrastructure perspective. Now, when it comes to the application, what it will have, the application that we will be deploying and that is being managed by Argo CD. So this application is exposed via ingress. Okay, and then this ingress will have multiple endpoints, but the endpoint that we have exposed externally to the ingress is the front end. Okay, so this will redirect the traffic to the front end pod that is behind a deployment, and then there'll be communication between front end to back end to database via internal endpoints. Okay, so these are all the internal services that will be referred from front end to back end and back end to database. Now database will have a persistent storage, so we have used 𝗶VC and 𝗶V, which is backed by an Azure storage class. Okay, and this is Azure disk, as you can see. Now it will also need some credentials. So these credentials are managed by external secret operator. We have used an external secret operator. So the credentials will be generated over here at the runtime, and then it will be referenced from the secret store, and then it will be stored in the key vault. Again, the kubelet will have to authenticate via managed identity to access the credentials from the key vault. What are these credentials? These are credentials specific to database, like your database username, password, host name, and all those details, right? Details that we cannot keep in the GitHub repository, or we should not be keeping in the GitHub repository. We could have used Kubernetes secret itself, but as you are aware, Kubernetes secrets are encoded, it's not encrypted. Okay, it's base 64 encoded, so anyone without a private key can decode it. So that is why it is important to use uh, a secret operator to interact with Azure Key Vault. Okay, so this is what all we'll be doing. Okay, so let me just open my GitHub repository as well, and where it is, Terraform Azure. Okay, okay, and if we go to lessons and then day 28, because this is the last video of the series, I hope you are enjoying the content so far. I have noticed that many of you, actually most of you, are just watching the videos but not subscribing the channel. Please do so if you want to support the channel, if you want more content to be published on a daily basis, on weekly basis, and I should be able to produce with the same speed. So make sure you subscribe the channel. Okay. Okay. So these are all the steps that we have to perform. There is some prerequisites. We are in day 28, so I'm sure these prerequisites are already there, which is Azure CLI and Terraform installation. So this is already there, and also Helm. Now you have to authenticate using a service principal. So let's do that. If you don't have, oh, so this is just the easy login, and then you can just create a service principal for Terraform. Okay, so we'll start from here. So get your subscription ID and then create the service principal with the contributor role. We might need network admin role as well, or network contributor role as well. So I think I already have a subscription with that. I think I already have a service principal with that role, but if you don't have it, if you face any permission denied issue, make sure you also attach network contributor role. Okay, so okay, before that I have to clone the repository, right? I'm not sure if I have written this step over here. I might not have, but that's okay. So what you can do is you can just go to this code and copy it, and then you can just clone the repository over here. Git clone. All right, now let's go inside the folder and then lessons day 28. Okay, let's open it over here as well. Okay, so this is what we have. Now I will walk you through the code. Just let me do some prerequisites and then I will walk you through the code. So this is the where are the prerequisites? Okay, so let's start with creating service principal for Terraform. Okay, I have just copied the command and I'm just gonna paste it. It's just creating the service principal with the contributor role. And do I already, yeah, it says found an existing application and a role assignment already exists. So I already have that service principal with the required role, but it will not do anything because it's already there. If you are doing it for the first time, make sure you have this role plus network contributor role. Okay. Now you need to authenticate yourself with the service principal credentials. So you need to export these variables. Okay, I have already, okay, let me check if it's already there. So let me just check, maybe client ID. Yeah, it's already there. So for me, it's good. But if you're doing for the first time, when you created the service principal, you will get these details, right? Client ID, client secret, subscription ID, tenant ID. Use those and export those as the environment variable. All the instructions are clearly mentioned in the GitHub repository, so you won't face much issues. Okay. So now we have to create a Git repository for the configuration, for the GitOps configuration. Now, before that, let me walk you through the code. Okay. So as you can see, we have separate folder for dev, test, and prod. Okay. So that whenever we have to create a new environment, we can create a separate, we can keep the configuration separate, but using the same underlying configuration. So what it has, let's open the dev. So it will have all the details like main, output, provider. There are multiple ways of doing this, right? So there is one way of creating separate folders. So we have duplicated the folder and just made the changes in backend.tf and tf terraform.tf vars. Okay. But there is this way, and then there is another way in which you can create separate modules for each of the resources and then call that in any of these main.tf that is there in dev, prod, and test. Okay. As I told you, there are multiple ways, so feel free to use whatever suits your needs. Okay. So it will have the dev folder. Dev folder will have manifest, which is the Argo CD manifest. Okay. So this is where the Argo CD application will be deployed from. Okay. So it's of kind application because when you create Argo CD, it will also create a custom resource definition for application. And you can basically create an application. So all these concepts specific to Kubernetes, Terraform, Azure, we have completed multiple times in previous videos. So Kubernetes concept related to, custom resources, Helm, customize, everything is covered in the CK series. And all those Terraform specific concept is already covered in this series, Terraform, 28 days of AZ Terraform, right? And we are in the last video, so I'm not gonna go through all the concepts again in this video because it will be just duplicate of work and the video will go for 2-3 hours. I don't want to do that. Okay, so I'll just stick to the basics. I'll just explain the fundamentals and I'm sure it will be helpful. Okay, so this is the Argo CD manifest, which is of kind application. So using this particular YAML, an application will be created which will make sure that your GitHub repo, in this there is an application, should be synced to the environment in the real time. Okay, so it will have the repo URL. So this is important. In the repo URL, you provide the URL of your repo where your application manifest is. Okay, namespace sync policy is also important. It will make sure that application is self-heal meaning if there is any changes in the manifest, it should redeploy the application with the new changes. Okay, and create namespace is true. If namespace does not exist, create the namespace. Okay, so that's the manifest. Then we have some scripts over here. These scripts are required to do a few operations, such as it will deploy the Argo CD application first. So when we run Terraform apply, it will call these scripts internally. So this script particularly will deploy the Argo CD application. As you can see over here, it will make sure that your Argo CD application is up and healthy, and it will show the application status. Then install external secrets. This is again to install the secret operator using Helm. Okay, and then it will create a secret store type object that will be helpful with the authenticating with the Azure Key Vault. Okay, and let's see the other one, which is it's just for the cleanup. Okay, when we do the cleanup. So these are all the scripts. Now we have backend.tf. It will have details of your storage account name, resource group name, container name, and all the details of a backend file. And then we have external secrets.tf. Okay, not from here. Let's go from here, from main.tf. Okay, so what are we doing? We are just using a data source to get the subscription details. Then we are creating a local. What these locals will have: resource name prefix. So it will have environment name, which is acquired from the variable, and it is being appended to a random string. Okay, then we are using common tags to merge all the tags within an environment, and we are basically setting some local values for the Terraform, right? Key vault name, infra node, resource group name, and so on. Then there is this random resource we are creating. Again, this will be a little overwhelming if you are just watching the Terraform related video for the first time. All these concepts we have explained in depth in this series, so make sure you go through the series from day 0 onwards in the same sequence. Otherwise, uh, none of this will make sense to you, right? Now we start with resource group. So we are creating a resource group for the environment, and the resource group name will be variable resource group name hyphen the environment name, so that we know which resource group is for which environment, as we have multiple environments. Over here, AKS cluster will be created with all the details. Then we have RBAC access for Azure Active Directory. Then we have role assignment, and this role assignment is for like the current user to have the admin access to the cluster to manage and make changes to the cluster. Over here again, another role assignment to provide manage identity operator, because we need to have the ability to fetch the secrets from key vault and to manage it, right? So that's why we need this. We also need this network contributor access to basically manage the network resources. Okay, now this will wait the cluster to be fully ready before proceeding with the Kubernetes resources, because we'll be making some changes, right? And then it will generate some random password for the Postgres database that we'll be using. Okay, and then key vault over here, access policy for manage cluster identity, okay, for secret provider, and okay, database secrets are over here. So this block will be responsible for creating the database secret, because I've told you earlier, right? We'll be creating the secret and we'll be storing the secret in the key vault, right? So this will be creating the secret. Okay, and let's go ahead, and then we have, so first this one will create the username, then this will create the Postgres password, and this is Postgres database name, and then we have connection string. Yeah, all of these. So these were all the main configurations. Now we have some extra files like variables, provider, output. Output will have all the like output that will be printed on screen once the apply is completed. So all the values will be printed. Provider.tf will have all the providers that we have used, like Azure RM, Random, Helm, Kubernetes, and all of these. Now here is Kubernetes resources, so in which the Argo CD application will be deployed. You see, first it will say over here we are creating the Argo CD namespace. Okay, so resource is of type Kubernetes namespace, internal name is Argo CD. Okay, and then we install Argo CD using Helm, so that's why we need to use the Helm release resource type over here. Okay, and all those details. And I mean, in this script only, the internal script that I have shown you will be called. Okay, for example, over here, as you can see, it is deploy Argo CD app.sh and then manifest. So we are creating a null resource. Null resource is to create a resource that does not have a resource type, but this is internal based on what we add over here. Okay, and then we are providing a trigger, like when to create the resource. So once the cluster is ready and once everything is ready, so use these details like cluster ID, Argo CD, ready status, and then provide the script over here, manifest over here, and all the details, and then execute the script. Okay, so this is a provisioner of local exec that we are using, and we are basically running this command to deploy the Argo CD application. Okay, and then this is for the cleanup, and yeah, so these are all the main resources. Similarly, we'll have same resources in prod and test folders as well. So I'm going to just test the dev, and prod and test you can do it by yourself, and feel free to let us know if you are facing any issues. Okay, so let me just follow the repository over here. The first is to clone this repository over here. Wait, clone your new repository. Okay, so we need to create a new repository with the GitHub GitOps config. Okay, so I'm just gonna copy this, and let's create a new repository. Repositories, new. Okay, I'm gonna give this the same name, GitOps-configs. Let's keep it public, add a readme, and create the repository. Okay, now you need to clone this new repository. Oh wait, yeah, you actually need to push the files from your manifest files folder to this particular repository. Okay, so what I will do is, okay, I'm not cloning it now because I have already cloned the other repository, and then it will be just confusing. But make sure yeah, like you make the changes over there, and feel free to make your own changes. So for now, what I will do is I will update the file which is inside 3-tier config folder. Okay, and we need to make certain changes, so let's do that. Okay, so go inside dev, manifest files, and these are all the files that we need to verify and make the changes. Okay, so let's go in this and let's update. By the way, 𝗵𝗹 is the person who is helping me out with all these content these days. A huge shout out to 𝗵𝗹 for creating this amazing project. I'm just gonna replace it with my name over here so that my repo URL will be synced to the repository that I've just created. Okay, so this is the repository that I've created, and now the path is 3-tier config, so there'll be a folder inside that, and inside that folder there will be files. So this is what it will look for, or we can just do a dot if we don't want to sync on a particular path. If we want to sync on the root path, we just have to write dot. Okay, so for now, let's just keep it the way it is. And this is the namespace. Okay, everything else is fine. So let me save this file. Let's go to the next one, which will have a config map with deployment, backend, image name. Let me replace it with mine. Okay, and this is the project that we have used in day 27 folder. So there is nothing new in the project from the project perspective. It just we are exposing it with the help of ingress, and yeah. So this will have the backend details. Okay, backend deployment. Okay, so config map and backend deployment. Then external secret. Let me see if we make any changes over here. Okay, so keep it as it is. Now front end, in front end as well, let me just replace with my repository. This is public image that I have. You can use this as well, or you can build your own image. I have shown that in previous video as well. Okay, now customization. If you are new to customization basically a tool to manage multiple environments in Kubernetes, and using a template file you can make the changes. For example, this customization file is referring to all the resources, like all these YAMLs. So whenever you have to make the changes, you don't have to make the changes in all the YAML, just make the changes over here. So these are all the common changes. For example, namespace. So that means we don't have to mention namespace in all those files separately. We can just write it over here, and then we can just refer it inside the YAML. Similarly, the common annotation, image name, we can just refer it over here. Okay. All right. So the tags that we are adding over here, we don't have to update these tags in the previous in all the separate YAMLs. Okay. Let me just update the version to V1 because we have two application version. I want to show you how it will detect the drift or how it will update the application when there is a new changes. Okay, so here are the replica count, 2 front end, 2 back end, 1 Postgres. That's okay. Now namespace.yaml, this is the namespace that it will be creating. This is for PVC and deployment. Yeah, I don't think we need to make any changes over here. Okay, this is also good. Now let's go back. Now it does say to update the repo URL, which we did. Then commit your changes to the GitHub repository. And okay, so now what I'm gonna do is I will create a new folder over here. Yeah, let's create a new folder with the name. What was the name? In Argo CD application. So this is the path. Okay, so just copy this. Okay, it's great. Maybe let's just create a README file. Day 28 manifests. Okay, now let's upload all the files over here. Documents, TF from Azure course, lessons, day 28, manifest file, 3-tier configs. Yeah. Am I in the correct path? Let me just verify it quickly. Okay, I think I am. Okay. Now this is done. Let's commit the changes. Okay, so our GitOps repository is done. Now we need to make the changes in our Terraform TFR files. So let's go back over here in the dev folder. Let's make the changes. This is good. Over here, it's my repository. GitHub configs folder is good. Let's make the application deployment changes over here. And okay, this is good now. Let's see in variables. Okay, let's make the changes over here. And I mean, these will be overridden by TFVars, but just in case I'm making the changes. Okay. And these passwords, etc. over here, if you can see, these will be ignored because we'll be creating new password, right? So this is just a placeholder for default password. You can remove it if you want. Now, also a terraform.tfvars, it shouldn't be uploaded to GitHub repository. It's for your local reference. So you can provide those details in that. That's okay. Now, okay, these have been verified. I think we should be good. Let's proceed further. So I've made the changes over here. And yeah, if you are testing it for test and prod environment, do the same for other two folders as well. I'm just doing it for the first one. And then validate GitOps repository. Check if your repository is publicly accessible or not using a curl. You can do that. And let's update the backend as well. Okay, because I'll be creating a new backend. Okay, so I'm just gonna run this command over here. It will create a resource group for Terraform state. Then it will create a storage account. It will create a storage container, and then you have to update the backend.tf with these values. Okay, so let me just go over here and run this command. Okay, it won't take much time. So it should be good. Let's see. And after that, we'll just run the Terraform commands. Let's see. Okay, so just update these values in your backend.tf. Let me just copy this backend.tf. Okay, resource group name, storage, container, and key. Okay, let's just replace these. Okay, let's save this. Now I have to go inside the dev folder, day 28 and dev, and run. Let me set the alias first, tf equal to Terraform. Now I just need to run Terraform plan. And no, before that I have to initialize the backend because we are using a remote backend. What does it say? Error retrieving storage account, resource group name is rg Terraform state. Maybe there is a mismatch of the name. Let's see. In the backend we have rg Terraform state, and what we have created, the one that we have created is rg Terraform state. That's okay. And okay, I think from somewhere it says invalid client secret provider. Okay, let me check what has been created. Resource group, rg Terraform state. Okay, and this is the storage account name. Okay, let me see if there is anything referred inside 𝗵𝗏𝗧𝗂𝗏. No, this is okay. Let's go inside variables. No, this looks good as well. Did I not save the file? Okay, let's see. rg Terraform state, and this is the storage account name, which starts with 175 and with 23 17523. Okay, and key is dev/terraform tf state. Okay, inside that, if I go to storage browser, containers, yeah, there is tf state over here. No, but it says dev/, so maybe Okay, that's the container name. Sorry about that. Inside that we don't have anything. It will be created soon. uh, this is okay. It says invalid client storage account name. Ensure secret being sent there is the client secret value, not the client secret ID. Invalid client. These all details looks good to me. No issues with these. Okay, let's go back. Okay, so we have resource group creation over here. Then inside that we created a storage container, and then it has a key for the TF state, 𝗓𝗲𝗏 state, 𝗓𝗲𝗏 state, 𝗓𝗲𝗏 state. Resource group name is same across all the commands. Then TF state with the date, storage account name. Over here is storage account name, that is also good. And what do we have in, let's see, what do we have in example.tf? Okay, so this is just a placeholder. Okay, let me just pause it for a second and then check the files. Okay, so it looks like my client secret was expired for the service principal because it was an old service principal. So what I did, I went over here to app registration, found my service principal, which is over there, Terraform AKS GitOps, went inside client secret, deleted the already present client secret and created a new one. And then I have just replaced this. I've just copied this value and replaced it over here in my environment variable with export command. Okay. And when I run the TF in it again, it worked. So that's the only change I did. And then let's run TF plan and see if it will be creating all the resources. Okay, it did not throw any error. So that's a good news. It says 17 to add. So I'll just apply the changes and I'll pause the recording. Once it applies all the changes, applies all the configuration and everything, then I'll come back and we'll proceed with the rest of the steps. There are few more steps. It's not just the infrastructure provisioning that we are doing. We have to implement GitOps and we have to test it out with making changes to the application. So I will have to show you few more things. So make sure you stay till the end because it's not complete yet. Okay. Okay, it has been completed now, and as you can see, all the output variables have been printed as well. So let's proceed further. We need to configure the kubectl access so that we can access the cluster. So let's run this command over here. It will create the credentials for, like, it will generate a kubeconfig for you, and then you can run get nodes and get namespaces and whatever command basically that you want. Okay, so let me clear the screen and paste it over here. Okay, so my cluster is ready. I can see 2 nodes and these are all the namespaces. So that looks good. Let's proceed. Let's verify the Argo CD installation. So I'm gonna do, let's create an alias first, kubectl. Okay, so k get pods in the namespace Argo CD. Okay, I see all the pods are running, including the application controller and Argo CD server. Everything is running. Now let's check the kget service. Okay, I see there is this Argo CD server exposed on this external IP. So let's copy this IP from here and let's open this. Now here is our Argo CD server which is running. Now we need to get the username and password. Username is, I believe, admin, and password we can get from the environment itself. So let's go back to the repository and I believe this one. Okay. So let's run this command. Is this the one? Because our password will be stored in key vault, right? So let's run this command. Okay, this is the key vault name. This is the key vault ID. And this is the client ID. Okay, now we need to update the GitOps repository with the key vault configuration. I'm just looking where are the details of Argo CD. How do we get the Argo CD password? Okay, we'll check it in some time. I believe it will be in one of the next steps. Let me see. Tenant ID, key vault name. Yeah, I think we have missed that step over here, but that's okay. I'll check this shortly. Okay, what we need to do now, we need to update the GitOps repository with the key vault configuration details that we have just printed. Okay, so go inside 3-tier config key vault secrets.yaml. Inside this folder there will be a key vault secrets.yaml. Not in this one, I believe. Let me see. Secret provider class. This one. External secret. Do we need to create a new file? When I tested this earlier, it was already there. But let me just check in this folder as well. Inside this manifest. Manifest files. Yeah, that file is not there. So let's create a new file. That's okay. Okay, I'm just gonna copy this. Okay, and let's add a new file over here. Gonna name it key vault secrets.yaml, or name it whatever you want, that doesn't matter. Okay, let's paste the value over here. And what we need to update, so basically it's commented what we need to update. So we need kubelet client ID. Let's go back. Kubelet client ID, where it is. Azure tenant, keyword secret provider, manage identity. Okay, this one over here. Keyword client ID and keyword client name, keyword name, which is this one. Then we have Azure tenant ID. Azure tenant ID which is from here. Let me run this command again because it's too messy over here. So let's get it. Tenant ID. Okay, and we need to update the key vault name over here as well. Key vault name. All right, these 4 things we need to update. So let's update this. Now we have replaced the key vault related details, and like all of these things, you can done it in an automated way by executing this script. Okay, it basically does the same thing that we just did manually. Now, okay, these are the duplicated steps, so this is what we have already done. You can skip this one. Now we have updated the details and committed the changes. Now let's verify the Argo CD application. Okay, it says application is synced and healthy. We haven't tested it, so we'll just check it and verify if key vault integration is working. So let's run this get secret provider, and I don't see the secret provider class. Okay, let's see the all namespaces. No. Now I don't see the secret provider class. Okay, let's check the Argo CD. Okay, how do we get the Argo CD password? I think it will be printed in the Argo CD application pod. So let's just see. Get pod Argo CD hyphen namespace. Okay, Argo CD server. This one or application control. Okay, let's see Argo CD server first. K logs hyphen n Argo CD. K logs. Starting Argo CD API server.secret key is missing initialized admin password. K get secrets namespace Argo CD. Argo CD initial admin secret. Here it is. K get secret hyphen namespace Argo CD hyphen o YAML. Okay, and here's the password. I think this is encoded, so let's decode it as well. Base 64 hyphen D. Oops. Let's okay. Not the whole echo. Let's do an echo. Okay, and then let's do base 64 hyphen D. Okay, so this looks to be the admin password. Just gonna copy it, and here is our application. Sign in. Oops, what is the username? Let's check the username as well. Secret Argo CD secret. No, let's see. Default Argo CD username. Okay, password, we have got that. We got the password already. It is the correct one. Is this the special character at the end? I'm not really sure. So let's just try to remove the last character. Oh, yes. That was so silly. This like ampersand, it was just a special character appended, so it was not part of the secret. Okay, so we have our application over here and it looked healthy and synced. So let's open this. We have all the configuration over here. These are endpoints, backend, front end pod. Let's try to access the ingress. Where is the ingress? Oh, ingress will not work because we have to install ingress controller, I believe. And ingress resource is also not there. I think the GitHub repo has been overridden somehow, because earlier we had those things. Earlier we had. Okay, let's proceed further. I think it will be at the end. Okay, so here are the details. Sorry, my bad. So here is what we have just did to get the admin password, username, or if you don't have the load balancer, you can do a port forwarding as well. Now to get the application access, basically you run get application and you can just do a port forward. So let's run this command. Okay, now your application will be accessed on port 3000. So let's just do a localhost on 3000 and here is their application. Hello. And basically it added the record to the database. So our front end is working, fetching the record from the database, and this is being done by a backend. So that means all our application pods are healthy. And if I remove it, the database entry has been removed. So this is working fine. Let's go back. Now what else? Okay, so here is the ingress details. So it says your front end YAML already includes the ingress YAML. So let's go back to our front end component over here. And do we have an ingress over here? It has a deployment config and service. No, it does not have the ingress details. So let's do that. Let's try to add the ingress in the GitOps repository. Okay, let's go back over here. Config map, deployment, service. I'll add it over here. Okay, looks good. Commit the changes. And let's go back. Ingress have been created. Now you need to install the ingress controller using this command over here. So let's do that. I mean, you can enhance this project further by automating these steps of installing ingress controller as well. Using Helm or whatever method you want to. Maybe you have to create another null resource of inside the Terraform config, which will do all those things for you. So you can do that if you want. Now let's, yeah, also we need to, because we don't have a domain for the testing. So let's configure this. So I think it configured the domain because we ran the command. Yeah, so let's configure the local domain. What are we doing? We are actually adding the host name mapping inside etc host so that it will be treated as a local domain. Okay, so let's do that. It will ask you password because I have used the sudo command along with it. Oops. Okay, so it says front end ingress is accessible. So if I just copy this host name now and let's try to access, fingers crossed. Let's see if it has synced it already. It says last sync a minute ago. And do we see an ingress resource over here now? Let's see. Backend, front end. Oh, over here, front end ingress. So it has created an ingress resource. And here is the PVC as well. Okay, maybe it will take a few seconds, some time. Meanwhile, let's verify our application if it is healthy. Okay, let's do a curl over here first. No, something is not right. Cat etc hosts. Why do we have couple of entries? Maybe it was there earlier as well. So let me remove the previous entry. etc hosts. We remove this one. Okay. Oh, yes, that was it. So our application is now accessible via ingress. So let's try to add something, remove something. All our pods and everything is working fine. Now this is using application version v1. What if we want to deploy a new application? Okay, so let's go back to our ingress config over here and let's make the changes in customization. So we have customization YAML over here. Added this file and let's just make the version from v1 to v2 for the front end. So commit changes, and currently in the newer version we have deployed toggle dark mode light mode as well. So over here nothing is visible right now because this is application version v1, right? So if I do refresh, let's see if it's synced or not. Hasn't synced yet. It says succeeded 4 minutes ago. So let's wait for it to sync. I guess it will take 3 minutes because that's the time we have configured for the auto sync. Or you can configure the webhook if you don't want to wait for 3 minutes or for a particular duration of time. Okay, you can configure a webhook as well. For now, let me just pause the recording and let it auto sync. I can just do a manual sync over here, but I don't want to do that. I want it to auto sync because that's what we mean by GitOps, right? It should auto pull the changes. All right, I waited for around 3 minutes, and as you can see, it says succeeded a few seconds ago, and it was from this commit. It does not say it was a manual sync, it was auto synced. And now let's go back over here and let's hit refresh. You see, now we have the dark mode as well, and here is this toggle button, light mode and dark mode, and this is the new application. So to deploy, we just had to commit the change in the GitOps repository and it auto detected the change. What if we update this pod from manually from the application? Let's say kubectl get application -n Argo CD. Okay, it's synced healthy. And if I do get pods, what was the namespace? Hyphen n, I guess it was 3-tier web app dev. Okay, so what if we actually change the deployment? Get deploy. Okay, so edit front end and edit actually deploy and provide the namespace name. Oops. Okay, and let's just update the application image version from 2 to 1. Okay, So where it is, container. Ports protocol. Actually, let's update. Yeah, those details will not be here anymore because we have configured it from that side. So here it is, image front end v1. Let's update it to v1. So now it will make the changes. It will not restrict us to not make the changes. So it might have created a new pod. Okay, so it says terminating, still working on it. Let's see. Let's see if it allowed us to make the changes or not. I see one pod in terminating state and it's errored out. It's gone now. Now we have two front end pods. And if I go back and see it's still v2, right? So let's go back. Okay, and it did not let us make the change, right? It did not let us update the front end pod because it was being managed by Argo CD. So it restricted us to do that change, and still v2. We can only make the changes from the application manifest, which is the single source of truth, which is what we wanted, right? And basically that's it. You can you can have a look at this GitHub repository to verify and troubleshoot if you face any issue. There is a hell lot of details. It is more than enough to deploy and configure this application. So that's it for this video. Make sure you destroy all the resources, otherwise it will cost you a lot. So thank you so much for watching. I will see you soon with the next one, and please support the channel. Please like, comment, share, subscribe, whatever you can do that. Thank you so much.